Hi guys! In this video, we are going to do some vocabulary and introduction to prisms and talk about where our formulas for volume and surface area come from for prisms. Next week we will talk about pyramids and cones, and then we will talk about spheres. But if we can understand where prisms comes from, we can then use that to determine our pyramids and cones. So first off, when we are talking about prisms, we are talking about a three-dimensional figure. A polyhedron is just any three-dimensional figure with polygons as the faces. But in a prism, it has to have two congruent and parallel faces. Faces are just the sides of your figure. It is the polygons that you use to form the shape. And when we're talking about those congruent and parallel faces, we're talking about the bases. So if you look here, these are a bunch of different prisms, and they all have some bases, and then they have some sides that connect those two bases. So these are all different types of prisms. And what you can imagine is if you took a disc or a CD or something and then you stacked them all up, that would be like your prism because you're taking that one face and then repeating it all the way through. And that's what we have here. In this case, they took a triangle and then repeated it all the way through your figure. Now, one of our big keywords that we have to see is the term a base. The base in our common language means the bottom, but in math, it specifically means one of the parallel congruent faces of a figure. So if we're looking at this, the bases are those shapes that are being repeated as you go up your figure. But let's look at these prisms. Look at this hexagonal prism, for example. The base is not going to be that rectangle on the bottom. Because as you go up the figure, if you kept taking slices out of that shape, you wouldn't get that exact same rectangle. Instead, the base is going to be this side. Because if I took a slice here and here and here, all of those slices would show me that exact same hexagon. So those are my two bases. It is critical that you can identify the base in a figure, that you are looking for that shape, that if you cut slices out of your prism, you would get the exact same shape every time. If we look at this triangular prism, once again, that rectangle on the bottom is not the base. Instead, we're going to call this triangle right here the base, because as I take slices out of my figure going this way, so if I took a slice like this and like this and like this, and I mean that instead of saying a slice like that, right? If I took slices kind of going horizontally, if I took a slice like that, I would get a rectangle. But the slices that I would take would not be congruent. Versus if I took a slice kind of here, I'm going to get a triangle out. So what you see is that prisms they can be on their side, they can be up and down, but that base is going to be the figure that's the same all the way through. And then if you can identify your base, your lateral faces are all the other sides. So in a prism, the lateral faces are rectangles that connect the two bases. They're all the faces that aren't the base. So your lateral faces would be these guys. They'd be the ones that go around the edge, whereas this and that are my bases. And those are lateral. Now, I do want to show you this term oblique. Oblique is if you have a figure that leans over. So you just take the cylinder and just make it slanted, but you notice that the bases are still parallel, but they are no longer perpendicular to the outside edge. Why do you think that this figure is not oblique? This figure is not oblique because the base and the edge do make a right angle. Whereas here, those do not make a right angle. That is my right angle. So to be oblique, it means that your base and your edge of your figure do not make a right angle. The height is what we would call the distance between the two bases. And I say that because if we're looking at these prisms that are on their sides, the height would actually be this length. It's kind of how many slices of triangles you're making in this figure. So that would be my height rather than this distance. So once again here, this would be my height because it is the distance between the two bases. And then the last thing we're going to talk about is the nets of a figure. A net is just the 2D representation of all of the faces. So it's when you unfold your shape onto a piece of paper. Nets are really awesome because they help us calculate surface area really well. Now, to talk about surface area and volume, let's actually go and make a figure. So here I have a polygon. It's a right triangle. And I'm going to take that polygon and turn it into a prism. To turn it into a prism, I am going to extrude that. And I'm going to say that it's going to be 5 units tall. Okay? And if we look, come on. So now I have this prism right here, and this is a triangular prism. And you saw to make it, what we did is we took that triangle and then just pulled it up so that throughout our shape we have triangles. And now we're going to turn this into a net so we can talk about surface area. If we look at our figure, and we can zoom out a little bit, I have taken that triangular prism and turned it into a net. So I took all of the sides of it and unfolded them. And what is kind of cool with this tool is you can see how I would fold it back up or unfold it later. Right, so I can unfold the sides. I can unfold the sides or I can fold them in. And you see how every face is getting a figure. So if I were to write on this, I would notice that my edge right here, I have one base and two bases. So if we're thinking of our surface area formula, right, I'm going to just do a quick sketch of that. We had a rectangle, a rectangle, a rectangle, and then another triangle. So these were my two bases. So if we're talking about surface area, we know that we're going to have two of those bases. And then I have 3 rectangles. So I have rectangle 1, rectangle 2, and rectangle 3 that I would have to find the area of. But let's think. So area of a rectangle is length times width. So let's think. The length of this rectangle. What is the length of this side? Well, that side that I was showing you over here is now the point from like C to J or B to H. That side is actually the height of our prism. So this is the height, and that's the same for every rectangle. Now, this is some side of our base. So now our formula is going to be HS1 for for rectangle 1, HS2, and HS3. So those are the 3 different the areas of the 3 different rectangles that we have. If I pull an H out of here, what did I just create? Well, this is this side 1 plus side 2 plus side 3. What part of my base is that? That's just the perimeter. So that's actually times the perimeter of the base. So our surface area formula is actually 2b plus ph. So what we're doing is we're taking those three rectangles, or however many lateral faces you have, and turning them into one big rectangle, where your side is where your width is the height, and then your length is actually going to be the perimeter of the base. And so that's where our formula for surface area comes from. Now, we could be more specific about how to find the area of the bases or the perimeter of the bases, depending on our type of shape, but I love this formula because it is super general. This will work for any prism or cylinder. All you have to do is find the area of the base and the perimeter of the bases, and you will have your area of your surface. So I like this formula because it is super general and it relies on your skill as a mathematician. Now, so that is where our formula for surface area comes from. It's the two bases plus those three rectangles. So these are the bases of whatever shape they might be, and then this is the area of all those rectangles. For volume, our formula for volume is going to be the area of the base times the height. Because what that is asking you is it's asking effectively how many of those slices of the base are going to make up the height of your figure. And if you put all those little slices together, you're going to get your total volume. So that is how we calculate volume. I want to show you those capital letters, B and P. This means the area of the base. So you are going to have to go calculate the area of the base, whatever shape that is, if it's a circle or a triangle or a trapezoid. You're also going to have to calculate the perimeter of the base. If it's a circle, then that would be your circumference. And then your height, that is the height of the prism. That means that it is specifically the height between the two bases. It's the segment that connects your two bases. And that is a little overview of some vocabulary related to prisms and where those formulas for volume and surface area of a prism come from. In the next videos, we will do some example calculations of volume and surface area so you can practice applying these formulas. Thank you guys for watching.